Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Is this an impression of your app telling a joke? Knock, knock. Execution timeout expired. The time period elapsed prior to completion of the operation or the server is not responding. In this episode, we're going to discuss several of the common performance problems that can occur when accessing a database over the network, as well as how to fix them. But before we get started, Will, what's been networking you this week? I don't know, that didn't come out as funny as I thought.
Yeah. Russian cursive is pretty is being a little bit rough at the moment because they've got letters that are the same shape, some of which have the same sounds, some that don't. But when you do them in cursive, you start from different places than you do in English. So like when so there's some odd things, and the problem is they've also got some letters that if you finish one letter and you're supposed to kind of like do like a little hook and then you start the next one. And if you don't, like you would in English, then that letter becomes a different letter because of the way that a lot of the cursive letters look very similar or have pieces that look similar. And so I'm having a little bit of difficulty with that at the moment. I'll get through it, but it's gotten a lot rougher. So in other news, I'm still continuing my Docker adventures. Now trying to play around with like multi-container setups and like setting up networks inside of Docker so that the containers can talk to each other, but they can't talk to stuff outside. Playing around with that. And that's been very interesting. And I guess the final thing I've got is we've been struggling with some database networking issues at work.
So that's where this episode came from.
Oh yeah. Cause it's like, you're just going through the thing. It's like, okay, what could it be? And you write down the list, right? And then you just go check those things. And I'm like, well, crap, that's an episode outline. I'm like looking at it.
Well, I'm really glad you did that because I was technically supposed to write the episode this week, but school has really kicked in. I had a quiz yesterday that I totally bombed, spent many hours studying for it, and still got a 5.5 out of 10. Not very good. There were a lot of questions from the book, and I haven't gotten my book yet, so yeah.
Well, your accuracy still beat the Weather Channel.
I have a homework assignment and a lab that I have to do tomorrow. They're due, I think, Friday, so I'm going to work on them tomorrow and possibly Thursday. And then part one of a research project due next week. So honestly, this class is a little bit more intense than I expected. Like, I'm a bit overwhelmed by and it comes in like Monday, the assignment is given for Friday. And I'm like, you didn't even give me a weekend to do it. I work and have a podcast. I'm like when I planned on doing my homework was, Saturday afternoon and Sunday afternoon. So I can't even do that. Yeah. Yeah. So I said something to the professor about that. So hopefully that'll get fixed. Let's see what else. My Albanian instructor is going to start giving me homework too. That won't be too difficult or time consuming. Not like Will's Russian homework. He's been doing it for quite a bit longer than I have, and he doesn't have anything else school wise going on. So, however, added to school and my guitar practice, time is quickly slipping away. Yeah. Well,
into the future. Sorry.
Yeah, time keeps on slipping into the future. Yeah, I know what you mean. Speaking of guitar practice, I set up my amp in a way that I can now play my phone through the amp. So I have recordings of our worship team. Basically, we have an app that has all the details about the songs and has various recordings for the different parts and stuff. And so I can actually play that through my amp now. And so I set that up the other day, and then I realized, hey, that's cool because I just been playing and then plugging my headphones into my phone. And so it occurred to me, I've got these really nice in-ear monitors that I use for the podcast. And on stage, everyone uses in-ear monitors. So it hit me, hey, there's a headphone jack over there. I can actually plug my headphones into that and use them as in-ear monitors. And so I set that up and it works really well. I can hear my guitar. I can adjust the volume and the gain on the guitar. So like I can either put it above or below and I can kind of hear it in the mix for the song. But it's definitely made made playing a lot better. Of course, these things have 3 speakers in each ear or 3 drivers in each ear. So yeah, there's a lot more bass in them than there was in the other like the cheap headphones I had with my phone. So yeah. And in final news, something kind of exciting happened today. I was at the gym and I was like, all right, actually on Tuesdays and Thursdays, those are my light days and I just do the 30-minute circuit. And I realized as I was like about to finish that I had skipped the curl machine because it's like where it is, it's like around the bend and the step, like the cardio thing is already past it. And so you get done and you look up and like there's a different machine right in front of you. So I just hop on that machine and I realized I was off by 1, typical development error. And so I went back and I did my curls and then I was there on the machine. I was like, I wonder how much I can max out on. So I put it all the way up, 150 pounds. And I two-handed curled 150. That's as high as the machine would go. There's another machine over in like the regular weightlifting area that goes higher. So next week, I'm probably going to try that machine just because I mean, it was a struggle to get 150, but that wasn't my max. So I think the other one goes up to 200 and we'll see. I'll let you guys know how that goes. But yeah, I personally thought that was cool. So because my normal routine, I usually do 35 per arm, but that's like 3 sets of 10. So, I was like, I don't know if I can do 150. We'll give it a go. And then I'll like kind of come down until I find where I'm at. And I did 150. I was like, I could probably do another one of those. That was definitely not my max.
Yeah. I also wonder what the difference is between machine versus, free weights on that. Just because the stabilization thing, I find that my max on a machine tends to be higher than on the free weights just because of the having to stabilize and having to worry about dropping it, which is the other fun thing. Saving money is hard, especially when you have to scale SQL Server to deal with network load.
Lucas Casares is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us here at CDP, he focuses on helping you to not only establish a real plan, but also to take action on that plan so that you can create and live your best life.
Guys, investing in financial planning services, it really comes down to whether or not you can improve your finances. And with the help of Level Up, the compounding impact of making better financial decisions will easily pay for itself.
And Level Up also has a unique pricing model that will help you no matter where you are in your financial journey.
Yeah, best of all, Lucas is a fiduciary for his clients, which means that he is not here to sell you a product. Instead, he is here to guide you to a better financial solution.
And you can find more resources and learn more at levelupfinancialplanning.com.
Database performance issues are the scourge of any large application, especially as load increases. They can be hard to understand, happen at times that aren't particularly predictable, and difficult to replicate in a development or even QA environment. This can make them very difficult to mitigate. The problem is compounded by the fact that many database performance issues are actually side effects of so-called proper code reuse and abstraction. As such, fixing them in a codebase can quickly become a problem on a team. A lot of people have read books on the right way to do things, but don't understand how to actually apply those rules.
Yeah, or when they don't apply.
Yeah.
In many cases. And given this, the process of troubleshooting database network performance issues in your application is really the process of piercing through a pile of abstractions to whatever depth is necessary to actually see what's going on. Really shallow bugs may be as obvious as a query that brings back thousands of records and doesn't need to. Deeper bugs may force you to have to dig deeply into how your ORM builds queries and how data is actually transmitted over the wire. Fixing these bugs may be as simple as caching frequently used data for a few minutes instead of constantly retrieving it from the database, while more complex issues may require pretty major reworks of your code base. The latter can be especially fun because it often has to be accomplished piecemeal while still allowing feature development to continue.
Yeah, that's very important.
And that feature development likely sits on top of whatever your code changes are, by the way, too. You're not doing it at the top of the stack.
Database networking issues can often be fairly counterintuitive to solve. While we like to believe that we can know what our code is doing by simply reading it, the truth is that we live atop a huge pile of abstractions, and a lot of which we probably didn't create. It gets even more interesting when our own abstractions work against us, or when our coworkers or our former selves, ourselves from 6 months ago.
And Will 6 months ago was a jerk.
Yeah.
Some of the code he wrote, fire that guy.
I got to be honest with you. The current Will is too. You haven't changed that much, bro. But when they slightly misinterpret an abstraction and create unintended side effects in application performance. Worse still, there are operations and infrastructure issues that can manifest in slow application performance while appearing to be problems with the application.
In this episode, we're going to discuss a number of different database network performance issues that may occur in large, more established systems. These issues don't tend to manifest immediately when you're just starting an application. Instead, they're kind of diseases of larger, more successful applications dealing with larger amounts of data, mostly. We'll also discuss how to troubleshoot and avoid these issues. In the aftercast, we're going to talk about ORM anti-patterns that contribute to database performance issues, as well as coding practices that can make these problems easier to troubleshoot when you run into them.
Yeah, I love how sometimes you say anti-patterns and sometimes you say anti-patterns. Like, I can't predict when you're going to say which. Like, I was expecting anti-patterons.
Well, what is the quantum state of me saying anti-patterns? Or anti-patterns. See, the thing is you don't know till you observe it.
That's true.
So it's Will's anti-pattern is like Schrodinger's cat.
All right. So on that, the first we're going to talk about is select n+1. This occurs a lot of times when you load a top level record and then individually load records underneath that record. I think it's called lazy loading. Is that right?
Lazy loading can be a cause of it. But it's real common when you misuse an ORM. So like, for instance, you load a list of invoices, you loop through the invoices and you go, okay, now I have this invoice. Let me grab all the line items under it. And then for each line item, let me grab all the, inventory slots, where it is in which warehouses, because I'm trying to figure out where to ship it from. And I'm, doing that iteratively. And so the growth rate of that algorithm is, it's what, quadratic, I guess, at that point? Or no, it's a little bit worse than quadratic.
Yeah. It would be.
Yeah, so it's basically the same thing, but you're doing crap over a wire instead of in memories, right? So it's the same kind of, same sort of problem. The thing is, in a lot of ORMs, your child objects can be retrieved transparently as you require them. So they enable lazy loading. Now, this is really convenient, especially when you're starting a new app out. And I would argue that you should do it early, at least for a while until things stabilize. And then you go back and you fix that because it doesn't scale. And it results in a lot of really strange and counterintuitive behavior a lot of times.
Yeah, I've run into that. What was really funny is right now I'm working more on front end stuff, but my last job was working with an ORM that it could be tricky at times, but it was the best option for the database we were using. And so it was fun. What was really interesting was when you would have an application that was built and used this ORM and everything like that. And then someone came in like 6 months, 8 months later and didn't understand the ORM. So they just wrote their own data layer.
Yeah.
And it's like,
yeah, you'll see that one too.
Like, why would you do that? Now there were times where an application had to talk to something else that wasn't that database like that. And so it's like, all right, it makes sense to have two data layers in that case. But sometimes it was like, why did you do that? So anyway, that's not really what we're talking about here. Sorry. So
yeah.
To avoid the select n+1, it's generally best to avoid lazy loading, as well as loading child records within the body of a loop. Yeah.
Yeah. Honestly, the way I look at it is load the crap up that you need before you do an operation.
Mm-hmm.
Then you do the operation. Like, don't do it while you're trying to do something else.
Yeah.
Because that means that structural changes in the other thing can lead to vastly different structural changes in the way that you access the database.
No, and it kind of depends on what you're doing too. Because if, like, for example, if you just need to pull up, all right, a list of all the invoices, and you don't need any of the deeper stuff. And then they they drill down and they click on it, and then you can pull up all the stuff for that invoice, all the line items, all the depth there. That's a little bit different.
Yeah, because they can't force the scale on the database at that point. This tends to be a problem when a computer is driving it. The other thing too, as far as like loading the records before you need them, you either try to load it with the parent record or in a subsequent call and get them all at once for the entire set of parent records, hopefully, because that limits the amount of database traffic that you're going to have. It allows for more optimal queries. Your database engines are set based, and you need to remember that, and don't think about it as a procedural thing. You got to do it a different way. But yeah, select n+1 is a pretty common killer of application performance just in general.
The next issue is filtering data on the wrong end of the wire. This occurs quite frequently when filtering criteria are complex, or when an object relational map or ORM exhibits kind of counterintuitive behavior. That means that a filtering statement is not applied at the database. And Will has an example of this, and so do I. So you go first, bro.
Yeah, so we were pulling back a list, and I'm trying not to get too deep into the actual implementation, but initially it was just, hey, we're looking to see if these items are in these set of statuses, right? Entity Framework translates that just fine. It does it into an end statement in SQL, which can hurt you if you get a big one, but it's not a big deal with like enum members, and that's fine. And then somebody's like, well, I really need to call this function over here. And when one of these records comes in, I've got to look at the status. I've got to look at some other piece of data that's sitting out here. I may need to do another database call. And that's fine-ish as far as how it looks. But what it resulted in was Entity Framework's like, yo, dog, I don't know how to translate this into SQL. So I'm going to pull the whole thing back and then run it through your filter. And it's a counterintuitive behavior. And we see that, every so often we'll find one. And they make themselves real obvious. It's pretty unpleasant because it's not immediately clear from reading the code which cases necessarily do that or not, unless you're very familiar with the data access framework and what it's capable of. Yeah. So like, for instance, doing stuff like saying a string starts with something. Well, Entity Framework can convert that into SQL. Even though it's a function, hanging in .NET, it knows how to translate that. But there's other string operations. I want to say like some of the regex and those kind of things it can't do. And that those things sit right by each other, and you would think, oh, I can do this here, but you can't.
Yeah, something similar happened to me, but it wasn't actually. This is interesting. It was we had this was a long time ago. I think I was still a junior developer at the time when this happened. But we had a developer leave. He was a senior developer. The type. You've worked with some. And he left right before this project was to go to UAT. So like I came in, wrapped up the last few things, spent more time helping the front end developer because he wouldn't transform the data at all for her or anything. And it was just like, you just have to deal with it. This is what I'm sending out. And so I did a lot, mostly just, all right, what it looks like in the database and what it needs to look like going to the UI are completely different. So I went and put a lot of that code in. But then it gets to user acceptance testing, and we had been working in dev and test with our own information in there. Well, UAT, they had copied over the production database so they would actually have their data to work with. And it slowed to a crawl because he was passing in. It was really, really brilliant. It's when I fixing this is when I really learned a lot about generics, and it really upped my skill level fixing this problem. But he was passing in a function to the ORM for the where clause, and it was not able to convert that into SQL. So it was pulling back the entire table, and it was actually a table with joins and subtables, and so this huge thing, and it worked just fine when there were a few hundred records. But you get 10,000 in there and it's slowed. You get 100,000 and it's crawling because they're pretty big objects and a lot more than that. And it was, and so figured out what was going on there and changed that up a little bit. But yeah, that was fun. So guys, There isn't really a great way to avoid this. At least not at the team level. Instead, you're going to want to monitor your system to look for sudden changes in performance. Like that's literally what happened to both of us.
Yeah.
So,
There's some team things that you can actually do to fix some of these problems, but this one, good luck. It honestly, it happens when somebody just makes a small change. Like that's the thing that actually burns you because it makes it where it can't be translated.
yeah.
And the other thing too you'll see is there's some people that'll just be like, oh, select star from this table, and then actually try to filter it in memory. You will get those people on occasion too. Or they'll do it with like a forms designer or something like that, where they've got like some drop-in component that does it, and they don't know how it works. Like I've seen that with like the Delphi forms designer and those kind of things.
Yeah. This code wasn't what I dealt with wasn't like that bad. I think it was just a misunderstanding of that particular ORM. I don't think he was as familiar with it.
Well, and it looks like it looks like something you can do well in code, like the whole Lambda function thing, and it looks like it's really clean and really neat, and it is. It's just you got to understand that when you're making something clean and neat, what you're really doing is you're putting the problem somewhere less obvious.
Yeah,
and that's like the extent of it.
Well, my solution was to wrap his function in an expression, and then it can convert the expression to SQL.
Sometimes.
Well, for what we were using, it could.
Yeah. I was going to say, mine, not so much.
Fair enough. Yeah. It depends on what you're
extra
doing.
Brackets on mine. It didn't help at all. Because, that was the first thing I tried. I was like, well, if it could do it, then I don't have to touch it and I don't have to test it at the level I would have to test. And the way you fix it is going to depend on your framework too, right? Because some of them do more or less than others. In a lot of cases, you may just need to revert to using raw SQL, obviously parameterized, in order to get the kind of performance you actually need. Sometimes you can't do it with your ORM in a performant manner.
Yeah, that makes sense.
Another issue that may come up is failing to cache or repeated invocation of the same thing to get the same data. Now, this frequently occurs with fairly static data that's used all over the system. A really good example of this in a multi-tenant system would be things like organizational settings. They don't change much. What's the name of the organization? Who's the contact person? What does their logo look like? Or what's the path of their logo? Hopefully you're not pulling the logo out of the database too. You may pull that data back continually. We had a situation at work where we were doing that and somebody had reused that method and actually had it pulling all kinds of crap. It was supposed to be pulling like a little flat table, and it was like child rows and aggregations and all this other stuff. And we weren't using it. In most of the places, it was being called in like 45 places. And there was the one place that was the original method call, and somebody else just chained their other crap on there, and it just brought the app to a crawl.
I caught a little bit of that today in some code I was writing, because I was looking basically repeating something in a different part of an app or of the app, but it's an Angular, and so I had to create another component because it was different enough where it needed a separate, like it couldn't be a generic component kind of like that. But I'm looking at their code and it's like, all right, well, when it's kind of like let's say we'll use a user system. So like you're adding a user, and when they would add the user, it would update the list of users to have that on there. And instead of just going, all right, well, post that to the database, get the ID back and then add that to the array, it would make a separate call, a separate get call. I'm like, not super bad performance wise, but
it's weird. Yeah. And like I guess this was over REST. Yeah. Like a pretty common thing is like do the update and then get the thing back that you updated, or, do the insert. Yeah.
Mm-hmm. Yeah. So it and that's the thing, like it was returning the object. So I was like, just, push the object onto that array and rebuild the data source. Like that saves an extra call. And if you got a slow, like if as a developer, we got like fast network performance, no problem. But some users, because everybody's working from home, some people are at home, and it's like, they may not have fast internet. And so that might actually be a pretty slow process for them when it doesn't need to be.
Yeah. And I've worked on apps that had that problem too. And you had somebody, suddenly start working from like Ecuador.
Mm-hmm.
Actually, that was actually the case. And the guy's like, man, this app just really does a lot of network calls to the same stuff because he was like tracing it because it was bothering him. It wasn't bothering anybody else. A lot of times when the app is requesting the same data over and over, it is literally the same data. Like it's very, very, very static. And even if you could pull it back with a really simple query, it's still extra network traffic and database usage. If you don't need to do it, don't do it. Yeah, these sorts of calls tend to live in middleware or in utility code, gets used across the system. So as long as your code base is reasonably clean, they should be reasonably easy to find. We had to do that at the tenant level at work, with like org settings. And it was pretty handy because the call that was causing the problem was in the middleware, but then we found that other stuff had been tacked onto it.
Yeah.
So it was pretty easy to track down with a middleware pipeline. Now, the way that you would do it in like old school.net, like back in the day, not so easy to find, and it's going to be on every page potentially.
Oh, yeah. So the best way to fix this is by using some sort of caching server, such as Redis, along with mechanisms to make sure that you invalidate this cache in the event of a change. We should probably do an episode on caching. Don't we already? We have that in the backlog, don't we?
I think we do. I put that as a note. And then I didn't follow up on it. That was actually for me to go back through and pull those as ideas. Sorry.
I don't know. Maybe we shouldn't put those in the same things that we put our other stuff.
Another common issue is a case where you bring back too many columns of data. So when you're using an ORM, the most trivial mapping you can do is an entity per table.
Yeah.
And that's fine, but it can mean that you pull back too many columns from the database. So it's essentially a select star by default. So you just grab whatever's in the table, you shove it into the object, and you call it a day. Right? Like it's the active record type pattern, I guess.
Another non-obvious cause of this is deep loading an object graph. In a lot of cases, this will be accomplished by the underlying framework using a lot of joins. So if you aren't careful, this results in a Cartesian product.
Yeah. So like if you're bringing back, the classic example, invoice detail items, right? There's two different ways to get that in SQL. One is a single call that gets the invoice as one data set coming back, and then the records for that invoice as another separate data set. So there's no repeat of the header record. And the other way is to just do a join and then split it when it comes back to the other side. And because of the complexity of some of the RMs, they like to do it with joins and then do the splits instead of separate result sets, because one may be dependent on the next one type stuff. It can be really gnarly to figure out. I mean, in general, you're going to want to be really careful to only load the data that you actually need for a particular operation when you need it because that increases the surface area where this can happen. And the thing is when you try to reuse your database access logic, you have to be extremely careful, and you got to make sure that each use case needs exactly the same data in the same shape, which is pretty uncommon when you have completely disparate operations happening on that data.
Yeah, that makes sense.
I mean, it's kind of like the DDD. What do they call it? Like not areas of focus. I forget the name of the thing now. Bounded context. You have like the big bounded context, and then the app you got like little semi-context type small areas that are totally different functions. And a lot of times people will load the same data for things that really don't need that data.
I like big bounds, and I cannot lie.
Well, you other coders can't deny.
So if you're using CQRS or command query responsibility segregation, you may want to use projections from your table for the query side and only deep load object graphs to the degree required on the command side.
Yeah, because a lot of times if you're reading from something, you don't want the whole thing. I mean, at the very least, you got audit trail columns and things like that. That's like, I don't care about this for this stupid display that I'm giving to the user.
Mm-hmm.
And so why send it back? Now, if it's a RESTful API, you may not know what the client actually wants in that shape. But then again, you probably have that in a DTO, and you still probably aren't pulling it all back and handing it to the client necessarily.
Or you may have, and this is what I've seen, where you have different calls for different levels of depth.
Or you can do that with REST and actually, you say, here's the columns I really want. And then you make a dynamic, knockout JS grid that can sort, and you can move columns around and do all kinds of. I've done that. That was fun. I would never want to actually do that for a situation where we had a tight deadline, though. That was not cool. But
so next is chatty calls. When a system is over abstracted, you may find that you're making a lot of small calls to the database. And like this was an issue that I was talking about earlier. Not to the database, this was to an API, but still similar concept. While you do want to limit how much you can bring back in a single call, there is still overhead for each call you make.
Yeah. And over abstracting code will definitely do this because you're like, oh, I already have a method to bring this thing back and I don't need to bring it back in this other thing. So you just chain the method together because that's what you would do in software that's not traversing the wire. But here you have an overhead for that call that's pretty substantial. And another common cause for it is lazy loading in a loop. So this goes right with the select n plus one. In fact, select n plus one is kind of a very, probably the most common type of this.
I'm going to say select n plus one is it is a type of chatty call, but yeah.
Yeah, it's like iceberg lettuce is a type of lettuce type thing. It's like it's most of the lettuce. Yeah, the thing is that it may not be immediately obvious that a database call is occurring when you do this in some circumstances. So this sort of thing is why a lot of developers really, really consider lazy loading to be evil and they disable it by default.
Yeah. It's lazy loading is tricky. Like we were talking about earlier, it can be very useful if you know what you're doing. The problem is
remember what you did last time.
Well, it's not so much that as it is you also have to trust the developers coming after you.
Yeah,
because that's what came to bite me. Is I spent some time learning to do it the right way, and of course this was kind of at that that point in your career where you're that mid-level and you're just like you're trying out all the really cool stuff and you're probably overusing it. Of course that's how you learn, but still it came to bite me when someone came in behind me who was not familiar with ORMs and just
or they were familiar with the version prior to this one.
Oh yeah,
and there's some underlying change. Like EF nailed us with that not too long ago. The way to avoid this is to load the data you need before you start doing work on it and to only load the data that you need. Mm-hmm. And this doesn't really play nicely with code reuse as a lot of people try to practice it. So like if they read, clean code or something like that, and they haven't really seasoned the way they apply it yet from experience, you can get here.
Yeah. So now is the one that I've been looking forward to this entire episode, the chunky monkey. No, wait, that's ice cream. Chunky calls.
Yeah.
The opposite of the chatty call is a situation where you're bringing back a large number of rows. And this can be the result of being overeager when loading the data you need, or when loading a bunch of extra data that you don't actually need.
Yeah, common cause of this is, again, deep loading an object graph where the root object has a large number of children. This can also occur when you join several wide tables or when you return large text columns. So you have a SQL and nvarchar max. It's like, hey, just put whatever text blob you want in here up to 2 gigs or whatever it is. And that happens to be in a column and you return that over the wire. That's not good. That's very unhelpful.
So to avoid this, be careful about how you structure objects in your ORM. If your tables have large columns, you may want to be careful about mapping them into commonly used objects when they're not really needed.
By the way, ORMs kind of give you a bias towards just saying a table equals an object. And that's really, really dangerous here. You can get into trouble very, very quickly. Honestly, in a lot of cases, you're going to be better off just retrieving projections of several tables in a flat structure instead of relying on a object graph. If any of the objects have big columns, or if you need to do aggregation on child records, or you're bringing back something that's like a really wide object that's got a lot of crap in it, and you only need like 2 columns out of it, don't bring the thing back. Project that into something else. And if your database framework doesn't do that for you, use a view and call the view, or use raw SQL and do something else. But don't bring the whole object back.
Views can be your friend.
They can be your enemy too.
Oh yeah.
That and EF migrations with views this week has not been the most fun either. Another example of a problem is failure to use connection pooling or cycling through connections too quickly. So this is a pretty common cause of poor database network performance as well. You have to kind of pay attention when you're allocating and deallocating database connections. In particular, this becomes a problem when you open a new database connection for each call rather than reusing a connection that's already open.
Yeah.
So most of your database drivers will let you pool connections, and they kind of handle that under the hood. But I mean, I've seen people, because they'll use a repository over a unit of work, they open a new connection every time a call goes into that repository during the processing of a web request. And so you get no caching at the connection level. You just get a lot of very strange stuff happening.
In SQL Server, this will show in the profiler with lots of calls to SP reset connection. If you are using connection pooling, but you may also see connections actually being opened and closed quickly if not. Both are bad signs if it happens too much.
Yeah, and the repository over unit of work pattern is exactly how that happened. And I have a long story that we probably don't quite have time for because it was a senior dev that did this previous gig. Now, to fix this, you need to manage database connection lifetime in your IOC container and scope it to a reasonable scope. In other words, like a single request in a web app, you get a connection, you go do the thing. And then that connection is injected into the things that need it. You don't new them up, because if you new them up every place that you need them, you're no longer managing connection lifetime, and you will leak at some point.
So next is failure to deallocate connections. This is the opposite of failing to pool connections. In this case, database connections are not deallocated or closed in a timely fashion. And what happens is this leads to issues such as connection pool starvation, because you don't have those connections there in the pool to use.
A really common cause of this is the use of languages that automatically manage memory for you. And now, I'm not saying that that's a bad thing. The thing is, with the advantage comes a problem, because there's a lot of stuff like database connections that you really want to deallocate in a predictable manner. And by the way, this does occur in unmanaged languages too. It's just usually the people that write those kind of problems in unmanaged languages, like, you never get there because of access violations and other things that they screw up. So like, you don't actually get to where you have this problem.
Yeah.
Because they can't keep the thing running anyway.
Another common cause of this is objects that own connections and have long lifetimes. You need to be careful how many of these you have, because if they're created in an unbounded manner, you're going to find that you are creating an excessive number of database connections when you really don't need that many.
Yeah, and you're not letting them go. So sometimes you'll see things. This is really common in like desktop forums, where somebody drags and drops a component on there, and it is owned by the forum, and the component owns the connection. Well, as long as that forum is open, that connection is allocated, even if it's not being used. If somebody pops open 10 of those, you get some weirdness really quick. And I've done that more times than I'd like to talk about. Again, like the previous example, the best way to handle this is to use dependency injection and inversion of control, and manage connection lifetime using policy versus trying to do it manually in all the places where it's used.
So the next issue you may see is antivirus.
Yeah, and this one's different, right? Because it doesn't exist inside your code.
It may cause database network performance issues if it's poorly configured or poorly written. Often, this software will make interactions with a database much slower than they would be otherwise. Yeah. And sometimes you don't really have a choice on this. Sometimes, like, you're forced to have this by your job. And so you get a Mac because they can't put it on a Mac, and then they find out how to put it on a Mac, and then you have connection issues that cause you lots of problems, and you have to reboot your modem. Not that that has happened to me today or anything.
Yeah, the thing is, you can detect this if your connection is otherwise fast enough. In other words, the server responds to a ping fairly quickly. Of course, antivirus can also interfere with that. But if it's pretty obvious that a connection from here to there and back is fast, the machine's fast, your machine's fast, it's something at one of the points where it gets onto the network, and it's very likely to be antivirus and or a few other things. The thing is antivirus is critical on a consumer-facing machine or a consumer machine, just in general. And it's really critical on machines with less controlled network connections. Personal laptops, people's home machines that have open Wi-Fi, those kind of things. But in a typical data center scenario, the connections are more tightly controlled. Of course, the information that is on those machines is also more valuable in most cases. So it doesn't mean that antivirus isn't important. It's just that it can be configured in a less disruptive way because you have other infrastructure that is also protecting the system.
Well, this is more of an operations thing. As a developer, you'll find that you're more often the person who discovers the operations issues, and you need to know how to prove that the problem isn't your code.
Yeah, because you don't want to, come out the gate and say that it's not my code.
Yeah.
So you have to actually prove it. And speaking of things that are not your code, another possible problem is poor cache performance. Sometimes you're going to find that even though you're following the previous recommendations and you're using a caching layer, that the caching layer is still slow or doesn't contain what you need in the right shape for some reason. So instead of, I need to get the organization settings, well, the only thing we have is this huge object graph that we serialized. Like, it's got to push that over the wire and you got to deserialize it. And that may still hurt your performance if you're hitting it enough.
Yeah. A common reason for this is a poorly configured caching server that doesn't have enough RAM or disk space. This causes things to fall out of the cache more quickly than might otherwise be expected.
Yeah, cache servers can also become a problem because, antivirus, firewall, network configuration issues, sometimes there's stuff, down lower that becomes an issue. And sometimes it's just because the caching server is located too far away. So like you're in US East 2 on Amazon or Azure. I think they both have a US East 2 now that I think about it. And your clients are in Taiwan. Yeah. Guess what? That caching server is probably not helping as much as you need it to, especially if all your other ops stuff is over there.
I mean, you want your caching servers close to your users.
Yeah,
really, you want if you're international like that, you want multiple caching servers.
Yeah, you want multiple caching servers, and you want them close to the edge. Same thing with a content delivery network.
Yeah,
which is really just a type of caching server in a lot of respects.
Makes sense. Yeah,
or it's an aggregation of them, I guess.
Now, this can also be an issue if the data stored in cache is not structured appropriately. For instance, if you need a small object and none of the rest of the object graph loaded, it doesn't help if the only thing in the cache is a fully populated object graph. That's what you were talking about earlier.
The other fun thing is when you get the thing that is there is the small thing and you need the large thing. It's like, okay, I got this little piece, but now I get to go get the rest of it. Like, that didn't really help me much, and it just gave me another failure point, which is the other thing to be aware of. And final one is kind of a combination of things, and they get confused. And so we're going to kind of talk through this. High latency or low bandwidth can also be an issue that can cause your database network connectivity to be slow.
Network infrastructure issues are a lot of times to blame for poor application performance due to high latency or low bandwidth. And now bandwidth is a measure of how much data can be transferred from one point in a network to another in a period of time, while latency measures how long it takes for data to go to an endpoint and return back. Interestingly enough, these questions about bandwidth and latency and how long it would take for, this much data to traverse this scenario were the ones I got right on my quiz.
So think about it this way. Let's say I take a van full of backup tapes and I drive it to Ohio from here. That is a high bandwidth operation. However, Ohio is, right, it's 6 hours away, or I don't know, Cleveland is more than that, right?
It's about
You're driving it up there. Yeah. And you got to do something with it at the other end and then bring the tapes back. That's latency.
Yeah.
And so those two things are kind of similar. They're kind of related, but maybe not because of, the other servers and other infrastructure that's out there. The thing is, you're going to want higher bandwidth and lower latency. And in general, because your application is interacting with services on other machines, high latency will hurt you worse quicker than low bandwidth will. This is one of the reasons why chatty calls are a problem, because they're really vulnerable to high latency, especially in scenarios where a sequence of calls occurs in a synchronous fashion. By that, I mean a sequence of calls occurs synchronously, not in asynchronous.
If you have low latency and low bandwidth, you can break down your stuff into smaller packets, and
you can cache aggressively too.
Yeah, and you can address that a lot easier than you can if you have high latency. Even if you have high bandwidth, high latency is going to come to bite you. Now, low bandwidth can become a problem when your application is transferring a large amount of data between 2 points. Such as when you're streaming or moving large files around, downloading MP3s. This is why we use like BitTorrent.
Chunky database calls.
Yeah, chunky database calls. Those chunky monkeys.
Yeah.
I don't know. Sorry, guys. I've been sort of eating healthy, and the concept of ice cream is so nice right now. High latency is typically also the reason why web pages with a lot of CSS, images, and JavaScript files are slow, because browsers will typically limit the number of concurrent downloads from the same website, essentially forcing you to pay attention to latency as a web developer. This is why you'll go to one of those clickbait sites and you'll start reading something and then suddenly the text jumps.
Yeah.
So annoying. Bundling resources helps, because bandwidth issues are easier to fix, typically, than latency issues.
Well, the thing about it is if somebody has a latency issue, they have a latency issue. If they have a bandwidth issue, they're broke. And they're probably not spending money with you. like that's a legit economic argument for fixing the one instead of the other.
That is
like at the Amazon scale.
That is fair.
That's not fair, but it's accurate.
Well, I mean, from their perspective, I guess. I mean, it makes sense. I follow what they're doing.
So guys, while database performance issues, especially over networks, are complex things, many of them can be traced down to incorrect usage of underlying infrastructure. In essence, these are physics problems that manifest as programming. And a lot of these problems occur as a result of abstraction hiding what's really going on under the hood, because you probably wouldn't do it the way that it ends up happening if you knew that it was happening that way. Once you get past the abstractions of your application and you can actually see what's going on at the network and database level, the source of the problem is usually pretty easy to find. Solving these problems, however, can be more difficult because it often requires rethinking the way that you use an abstraction within your application, or rethinking whether you use it at all. And it may require that you adopt completely different coding patterns entirely, at least for that part of the app. Pretty much wraps us up. Beej, what do you have this week for us for Tricks of the Trade?
So guys, connectivity issues aren't just for computer networks. The concept of networking or growing your network has been around for a while, and it's there. The idea is to reach out and meet people, either in your industry or in a field that you're interested in, things like that. And you can do this at conferences, schools, local meetups, or even non-tech events. For example, I'm leading a couple of small groups at church, and Sunday night, we're sitting around before our group started, just chatting. And one of the guys asked me what I did for a living. And I was like, oh, software developer. I lead a team doing front-end development. And another guy was like, oh, he got up from his chair, came over and sat down beside me because he's a Java developer. Turns out we went to the same high school, just a couple of years apart. But yeah, no idea. And this was at a church thing, but networking. Right there. However, sometimes you can have trouble connecting with other people, or, maybe not in an area where other people are that are in your field. I know we've had some people come to our meetup group when we had one who drove a couple of hours because they didn't have anything in their area. Yeah, this can be due to a lot of causes. Connecting with other people, communication could be just your own inability to communicate. We've had some episodes. Others may not be receptive. They may have blocks up, or there may not be the opportunity. Like Will was joking about recently during the quarantine, we all experienced a massive networking outage when it came to personal networking, or in-person networking, I should say. As such, a lot of us found ways to connect and even meet new people without being in person. I know I attended a couple of conferences that had breakout rooms where they just randomly put you with people and you chatted and got to know each other. It was kind of a cool thing. Got to meet a couple of really neat people that way. But what I'm getting at here is if you're having trouble connecting with other developers or finding other people in your field or something like that, start thinking about it the way you would a network connection and troubleshoot the problem. Like Will did. Will made a list of what could the possible issues be and how do I solve them. Don't be afraid to try out a novel solution either. If you're not one for going to conferences, when they start back up, check one out. Was hoping we would get to go to some conferences this year, but everyone that I've looked at has been virtual. So I think this episode's going to come out after Music City Tech. But yeah, that one's virtual this year too, which is why we haven't really advertised it, because the pool is coming and meeting us, and that's not going to happen. Guys, that's pretty much all I got. Check out the Aftercast, where we're going to talk about some object relational mapper or ORM anti-patterns that hurt database performance and data access practices that can help you troubleshoot performance issues when they occur.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.